Yeah. So I'll ask you some questions. Uh, Normal questions on your experience with various technologies, and on basis of that, I will decide what level to start with the next technologies. Uh, so with the next part of this internship. Right. So the first question is, how familiar are you with the databases? Any database like MongoDB, SQL, sorry, SQL, anything. Do you have any experience with databases? Okay. I need everyone to respond. Yeah, ask question. SQL beginner. How beginner are we talking? Basically, they are um, creating tables, adding something, and then removing something. That is the basic part. Then there's the foreign key creation, relation between two databases, two tables in a database. That is intermediate. On the basis of that, how familiar are you with the databases? Okay, so I guess we'll have to do SQL for a bit. And then, have you ever used an API in your program? Have you ever used an API anywhere in any language, basically? Second question is, have you ever used APIs? Are you familiar with how APIs work? Right, so we can do one session of APIs, I guess, right? Then, how familiar are you with regex, regular expressions? I see no responses, so I'll ask again. How familiar are you with regular expressions? Regular expression as in those set of characters which matches something in a string. Those are regular expressions. Okay, someone needs to reply so that we can go on. Santosh, am I really audible? Okay, so I'll assume you guys do not know what regular expressions are. Basically, even in equatorial basis. Okay. And I'm still looking for an answer on regular expressions. Okay, so how many of you have ever used object-oriented programming in any language? Basically, if you are a Java user, you have to work with uh, objects compulsorily, but still, who here has somewhat experience with the classes. So yeah, so the last question is, let's say you are given a problem statement basically. How comfortable are you solving it with Python? Because whatever whatever I've taught you till now is basically what is required to solve problem statements. So how uh, comfortable are you with problem statements? Okay, let me just reconnect. Okay, so my final question is, how familiar are you with the problem statements? Everyone's look at the chat box, please. Uh, Guys, if you do not respond, I won't be able to correctly tune the curriculum so that you understand everything that is going on, right? Because in the coming sessions, we'll be doing the scraping part, which requires the access. We'll be storing all of those, um, let's say, the data into the databases, and then you would need the object-oriented programming part to work with Flask. So I would need all of that. Okay, so I'll fine tune the schedule a bit. Okay, so I would recommend that all of you now um, start looking into SQL commands, right? Because in the coming sessions, when I start using the Python library for SQL, I will not be typing the instructions. You will be telling me what the instructions are, and I would type them as you say them. Otherwise, the SQL part will become very difficult for you. And it is one of the most important technologies. अगर आपको, let's say you do not know a language very well, but if you are fluent with SQL algorithms or data structures, then it is like it is better than not knowing a language basically. किसी language का syntax you can remember, but if you are not familiar with the databases, algorithms, and say data structures, then उस language का कोई use नहीं, right? So starting today, I guess we'll start with databases the next Monday, alright? So starting today, you should start practicing your SQL commands, like from creating a table to removing something, adding something, searching something, or creating foreign keys to establish connection between two tables. Right. You should start doing that, and you should start solving problem statements to improve your logic. Right. So I guess what we can do for now is I can go a little deeper into object-oriented programming now, and then tomorrow we'll start with the basics. Let's see. Is the screen visible?
Yes.
Okay, so as we were talking about last Monday, let me just comment it, object-oriented programming. So we all know there's this class thing, then the name, and then the attributes and the methods. Right. This is what a basic class looks like. But there are some things in class which are important that you understand before we go on to web development. The first thing is, first thing is class methods and class attributes, right? And the second thing is static methods, and the third thing is property. Right. Now all of these are important when we go on to the web dev part. So you should start with those. So we'll first start with what are decorators. Right. To understand these, you need to start with decorators. Right. So for starters, let's say we create a function. Let's call this the main function. Right. It takes another function, and then there's another function in a function. So let's call it wrapper, which what it basically does is say print inside wrapper function print executed function, and then let's say return return wrapper double P. Right. So first of all, we here created a function, and then inside this we get another function. Now this function takes takes another function as its parameter, and then we run this function here. Right. But we do not run this function inside the main function. But what we do is we return this function back to the user. Right. So let's run this. Let's say another function which it basically does is prints this is a function. Like now, let's say there's a variable main run. Alright, and we do main passing func1 inside it. We run this, it runs perfectly. Like now, what we do is now we do something like main run, and you will see main not fun main dot learn. We do this and use as you can see, this is printed out first, then this function is run, right, and then this is run. All right. So what happens here is we pass on this function to the main part, the main function. Then this function is defined, and then this function is returned. Now something that should have happened is when this function is returned, the wrapper function, the main function is removed out of the variable part. Right now, this function has no instances, so all of this should also have been removed. But what happens is the wrapper part actually grabs onto this function part, and when we run this, as you can see, this part should have been destroyed when the function finished executing, but it's not the case, and this property is called closure. Right, closure is a property when the code related to a function is attached to it, so that when the function is passed somewhere, it takes all of these variables with it, right, and then saves it in this. Right, so instead of this complete part being removed from memory, this part is retained due to closure. Right, so this may be a very difficult subject to grasp, but I'll share some examples in the classroom at the end of the meet. Right. So what this is called, right? This entire part is very important in Python. Right. When you use Flask, what happens is basically you pass in a function inside another function, which basically does some stuff before executing this function. Right. So what you're basically doing here is you are improving the functionality of this function here. Right. You are increasing the functionality of function 1 by passing it into the main function and then doing the extra stuff with. Right. Now, what you can do here is you can say func1, and then you can just run func1. Alright. And when you run this, it's the same output. Right. So what we did here is in this code is we changed the definition. Wait a second. Yeah. So, yeah. What we did here is we changed the entire functionality of function 1. That we added this part to this part, to this function. But what I mean is we added this part and this part to this function, which improved the functionality. Right. Now for this, Python basically has a special, let's say a special syntax. All right. Now the syntax is called the decorator. All right. So it goes like at, and then the function in which the child function is passed. Let's call it the parent function, the above one, and let's call this the parent function so you can understand. Now, the syntax is at, then the name of the parent function. All right. So I did this. I did not throw the function as an argument to the main function, but when I say func1, you can see it works perfect. Now this is what a decorator is. Right. Now we'll study some uses of it, but I need you to grasp the entire concept first. All right. So I just revise it. We have a parent function, right, which takes a child function, and then there's another function. This function improves the functionality of the child function, and then returns the improved function. Right. So in any other language, what we would have done is we would have first, let me just comment it. What we would have done, we would have done something like name of the child function is equals to name of the parent function, and then name of the child function. Right. Run this. Sorry, the function is passed, not the execution. The execution is passed, and then as you can see right here, the functionality is changed. And when we call func1 again, the improved code is printed out. Okay. Now this syntax is used so much in Python that it has been this thing is used so much in Python that it has been converted into a syntax, right? And that is at, then the name of the parent function. All right. Then we run this, and this is our improved function. All right. So when you write underscore main over a function, underscore the parent function over a child function, what it is doing under the hood is basically throwing this entire part to this entire function to the main function, and then returning the inner function basically, right? So let's say we want to pass in argument. All right. So let's say x, and let's do 5 here. All right. So now when I what this does is basically it will print x. When we do this, this will most likely give us an error. Yeah. So when you pass in a function, you pass in an argument in the child function, all of the arguments go inside the wrapper function, not the main function, not the parent function, but the wrapper function. All right. So this will work fine inside wrapper 5 and executed function. All right. So this is what is called a decorator. Right. Now this will be used a lot in Flask. So I basically wanted to tell you what it is, and I'll share some, I guess, YouTube links which explains them better. Right. So this is what a decorator is. Now how do we use it in a class? Right. Let's say there's a class name test, which, and then let's say there's this object count underscore count is equals to 0. And then we say there's a function in it, itself and name. Now we call self dot name is equals to 0. This is what it is. This is what uh, class is, as I told you. Now this is the class attribute. Like this is unique to the class. Right? This is not unique to the object. This is unique to the class. Right? As I told you in Saturday's class, this is a class attribute, and this is an object attribute. Everything with self is an object attribute, belongs to the object, while everything which is not with self belongs to the class. Right. So this is unique to every single object, but this is not unique to every single object. This is unique to the class. All right. So we know how to create an object attribute. All right. But how do we create an object class? So we use the @sign, then class method, right? And then the function, let's say up object, right? And then this takes an argument which is not self but the class CLS. We cannot use the actual terms, the actual spelling for class CLASS, because that is an already existing keyword, and this is a different meaning, right? So what we do is CLS dot object count plus 1, and let's say if we can call it from here up underscore count. This will most probably not work, but let's try. Let we create an object p1 which is test. Let's name it test1. This will give us an error most probably. Yeah, as you can see, it says up count not defined, right? But why is this? Is because you cannot um, call a class attribute from within an object attribute, right? But let's try this. I guess this works. No, this will not work, so let's just remove it. Right? What uh, is you saw right now? A class method is only called by a class. Let's say test dot object. Now when I run this, it executes completely, and if I say that, guys, wait a second. I'll be back in a second. Okay? So wait a minute. Alright. So when we do this and then we say this works, and when we print this, as you can see, it returns +1. Right. So this is a class method which passes the class attribute. The class is an argument instead of the object is an argument. Alright. This is what a class object is, and let's come to static method. Use the add static method syntax here, and then you say something like this prints for as okay. Now let's remove this and let's call test. Sorry, test dot enter capital T. And this is called the static method. Right, so where you will basically see static methods are with labels like math. Right. Now what this does is, let's say math dot sqrt of, let's say 9, and the square root of 9. It's a math library, right? It's the name of the library. Module. It's small and so it's small and as you can see, this printed 3.0. Right. So what static methods are? Static methods are the methods that are and that do not take any argument, not the class or the object, but what they do basically is they can be called without creating an actual object. All right. Now, a class method and a static method feel and work the same, but a static method is used such that is used when it has no correlation to the actual class. But as you can see, this has a correlation with the actual class. It one-ups the object count or the number of objects created, and this basically has no correlation to the object to the test class. Right. So this is what a static method and a class method is. Right. So let's remove them. And let's say the property now. Those of you who have used Java, yes, they know what the setters and getters. Right. Now this property decorator is used to set setters and getters. All right. First of all, you use the add property decorator, and then you find a function name right? And then it returns something. Let's return self.name. Right now, the syntax for this was this underscore setup. Right, and let's say self.name equals to self.name is equals to name. That is the syntax. Let's try this. Properly remember, but yeah. Let's create a test object even a test which goes basically, let's call it test one. Some this will give us an error. Yeah, that's nice. And let's say print self.name. Let's just comment it out. Now this is not syntax. Let's say self test.name. Right. Now let's look at this. Let's test one self.name is equals to name. I commented out the setter, then why is it telling me to use this setter? Okay, yeah. Set underscore, it's called set underscore name and get underscore. So the syntax. So the object name P1. Now this works. Okay. Yeah. So this is what is called a getter. This is called a, and this is called a setter. Now I can say something like t1.name is equals to something new and t1 dot and then print t1.name. Right? Do this. First the name was test1, then we changed it, and then we printed out the new name. Alright. Now what we could have done is we could have created another function, let's say name underscore get, right? And we could have returned self dot name. We could have done it that way, but then we would have to call the function. We have to go something like name underscore get, but this is not very reliable whenever you're using um, object-oriented programming, because let's say you make a change in your basic code. Let's say you make a change in your property, right? Let's say we don't call it name, we call it instance, right? So now we will change this function in then we change this to we change this thing to instance, and then we changed this to right. So now this you can see if I changed it here, so whoever was using my class will have to update this part. Alright, you will have to go instance underscore instance underscore get, right, and then they will have to print it. Right, yeah. Then you have to change this here as well. This, yeah. So if you do not use setters and getters, what will happen is the other person who is using your class will have to change their own functions to basically get and set something. Alright, so what this property decorator does, let me just still call it name. What this basically does is it converts this entire thing, this entire function, into an attribute which can be called by just using the actual name of the actual instance of the class, actual attribute of the class, right? So we would not have to put in these here or these here, right? It will just, when we say t1.name equals to this is basically passed here and set as a new name. Yeah, so this is basically passed here and set as the new name. All right, so we'll just summarize this. Methods, and properties. Right, so if all of this, what it does is creates, declares method as a class method, that is, it passes a class as an argument. What this static method does is basically it takes no argument, no self or class as argument, and is used for methods detached from the class. And the property decorator is basically used for setters and getters. Okay, so this is a difficult concept to grab, but it is really important, and it is one of the most important expert Python topics. So I'll share some links, YouTube links, which explain them a little more, and you'll have to practice them yourself and see what they do. So yeah, does anyone have any doubt? So, does anyone have any doubt regarding today's session? Hello, am I audible?
Yes, sir.
Yeah. So, if anyone has any doubt regarding today's session, they can ask me. Then I'll talk about the assignment I gave. Yeah, I'll send you some links from YouTube because it is a really difficult topic to grab. But if you grab it, your the object-oriented paradigm of Python will really improve, right? So I guess no one has any doubts. And regarding the assignment, I think everyone saw the assignment, right? So in the assignment, I basically explained everything. I explained everything from all the specifications and everything. So if anyone has any doubts regarding the assignment or the logic behind it, they can communicate the same problem to me and I'll solve it. And at the end of the uh, solution period, I will share the entire um, solution with you. Right. So thank you everyone, and I guess that's it for today. Now you can leave.